So in our last class, guys, we were talking about measuring motion. You learned about what motion is and how to measure it using a distance-time graph, and we practiced using that. Now we're going to be talking about what makes an object move, what puts it into motion, and that would be forces, which we're going to talk about today. Now, we're going to be getting into rockets in much more detail when we get into astronomy later, but rockets are a great example of forces at work. If you were to have seen the space shuttle in this picture before it was taking off, it was just sitting on the launch pad. There are forces at play here, even though the shuttle is not moving. The forces are balanced, though, and we're going to be getting into balanced forces and unbalanced forces. But right now, the surface of the launch pad is pushing up on the shuttle, while gravity is pulling down on the shuttle. But they're balanced, so the shuttle's not moving. Eventually, though, the fuel inside of the shuttle and the fumes and the exhausts are forced out, and this is called thrust, but we'll get into that later, which creates an unbalanced force. So now we have the force of the exhaust coming out that's actually pushing the rocket up. And this is what force is, and we're going to be getting in a little more detail on that right now. But a force is a push or a pull that acts on an object, okay, such as pushing a grocery cart or pulling a door closed. Forces cause objects that were once at rest, it causes them to move. It also causes moving objects to accelerate by changing speed or direction. And you learned what accelerate was in the last section. This is any kind of change in speed or direction. And when you think of the word accelerate, I know you kind of think of when you're driving a car, when you accelerate the car, it goes faster. But don't forget, you can have negative and positive acceleration. So the slowing down of an object, that object is also accelerating. Now, when we measure force, we use newtons, okay? This is the amount of force on an object. So I'm not going to expect you to memorize this, but I just want you to understand 1 newton equals the force that causes a 1 kilogram mass to accelerate at a rate of 1 meter per second squared. And of course, named after Sir Isaac Newton, and we're going to be learning a little bit more about him later. Okay, so we use arrows to represent force, okay, and the strength of the force, you would have a longer arrow, and the way the arrow is pointing is the direction that the force is going in. So as you notice here, we have a short arrow, which means that it's a smaller force, but it's moving to the right, okay? Over here we have a larger arrow, which would indicate a stronger force, and that is also moving to the right. Okay, so rarely, if ever, do you have just one force acting on an object. There's usually multiple forces, and multiple forces could be working together or could be working against each other. So when you have forces that are in the same direction, because they're working together, you add them. So you have a small force here that's at 2 newtons, and it's working together with another force at 2 newtons. So you just add them, and the force that's moving a particular object is working at 4 newtons. Now you can also have objects that are working against each other, okay? And that is depicted by arrows that are pointing in opposite directions. So you have a force of 2 newtons pushing to the right, and you have a force of 4 newtons pushing to the left. Well, which one is stronger? Of course, that would be the 4 newtons pushing to the left, so left wins. and we have 2 newtons to the left. Okay? And then if our forces are equal but opposite, we have 2 newtons to the right, 2 newtons to the left, they kind of cancel each other out, and we end up with 0 newtons. And whenever we have 0 newtons, that means our object is at rest. It is not moving at all. Okay, so net force is the adding or subtracting of all the forces that are working on an object. So here we have a box. This is our object. Okay, and we have 3 different forces working on this box. We have a force that is pushing at 8 newtons to the left, and then we have 2 other forces here. One is pushing at 3 newtons to the right, another is pushing at 1 newton to the right. 3 plus 1 is 4, so we have 4 newtons this way, 8 newtons this way. Well, which one is stronger? That would be our 8 newtons. 8 minus 4 is 4. That would be our net force. And because it is stronger on this side, then our object is going to be moving to the left. Now, not all forces are unbalanced. Sometimes they're balanced. And when they're balanced, like I said before, the object does not move. So for example here, you have 4 newtons pushing to the right. You have 4 newtons pushing to the left. 4 minus 4 is 0. Okay, whenever you have forces working against each other, you're going to be subtracting. All right, whenever you get 0, that means your forces are balanced and the object is not moving. Okay, here's another one with unbalanced forces. We have 6 newtons from one force, 6 newtons from another force. They're both pushing this object to the left. And then you have 3 newtons working over here, pushing this object to the right. Well, which side is stronger? That would be over here. 6 plus 6 is 12. So we have 12 newtons to the left, 3 newtons to the right. So because these 2 forces are working against each other, we subtract. 12 minus 3 is 9. And because it's stronger over on this side, the object is being pushed to the left. So it would be 9 newtons to the left. So just always remember, if it's an unbalanced force, you'll have some number other than 0. If it's a balanced force, then your net force will be 0. Okay? Any number that is not a 0, that force is causing acceleration. It's causing either some kind of change in the speed or direction of the object. Okay, and then we're not getting into the section on friction, but you should at least have an idea of what friction is. And it is a force that opposes motion. Okay, so it's kind of working against motion. So if you had a box on a floor, maybe you had books in it or something, and you push that box, you're going to have resistance. And friction is one thing that causes that resistance. It acts at the surface where the objects are in contact. So where the box meets the floor, that's where friction takes place. And you should know that friction produces heat. If you've ever taken your hands and rubbed them together really fast, you'll notice that your hands are going to warm up, especially in the temperatures that we are having lately. And friction is higher the rougher the surface. So if you're pushing a box across a really smooth surface, you're not going to have as much friction. But if it's on a coarser or rougher surface, then you're going to get a little more friction working against the force of pushing. Okay, well, in class we're going to be doing a lot more practice with different forces, balanced and unbalanced, and calculating the net force. But if you have any questions, you can see me in class, or you can also watch this video over again. So I will see you guys in class.